Alright, dude, let's go. Number 10. The Farewell. In 1977, NASA's Jet Propulsion Laboratory launched 2 spacecraft from Cape Canaveral, Voyager 1 on September 5th, Voyager 2 on August 20th. Their project scientist, Edward C. Stone of Caltech, oversaw both missions for 50 years. He died on June 9th, 2024, at the age of 88. In February 2025, engineers shut down the cosmic ray subsystem on Voyager 1. In March 2025, the low-energy charged particle instrument on Voyager 2 followed. Each probe now operates on approximately 220 watts, less than a household refrigerator, running 3 instruments on computers with 68 kilobytes of total memory. The part nobody talks about is what happens when the signal stops. Voyager 1 is at roughly 172 astronomical units from Earth. Every signal it sends takes over 23 hours to arrive. In November 2026, it will reach 1 light day from Earth, a distance so vast that a message sent at the speed of light takes a full rotation of the planet to cross. Engineers at JPL are cannibalizing software to keep the probes alive, deleting code from the 1979 Jupiter flyby to free memory for critical systems. By the early 2030s, the last science instrument will go dark. By approximately 2036, the signal will fade entirely. After that, 2 golden records carrying the sounds and images of Earth, thunder, birdsong, a mother's greeting to her newborn child, will drift through interstellar space for billions of years. In roughly 40,000 years, Voyager 1 will pass within 1.7 light-years of the star Gliese 445. There will be no one aboard to know. The farthest objects humanity has ever built are dying. When the signal fades, they become ghost ships, carrying our voice into a silence that will never answer. Number 9. The Vanishing. In 2019, planetary scientist James O'Donoghue, then at NASA Goddard Space Flight Center, now at JAXA, published a paper in the journal Icarus, documenting a phenomenon called ring rain, ultraviolet-charged ice particles from Saturn's rings spiraling down the planet's magnetic field lines into its atmosphere at a rate of 432 to 2,870 kilograms per second. 2 years earlier, during NASA's Cassini Grand Finale, 17 orbits that threaded the gap between Saturn and its rings before the spacecraft was deliberately destroyed on September 15, 2017, instruments measured a far worse equatorial infall rate of approximately 10,000 kilograms per second. NASA described this as enough water to fill an Olympic swimming pool every half hour. In 2023, Sasha Kempf of the University of Colorado Boulder published measurements in Science Advances constraining the ring age to no more than 100 to 400 million years. But the edge-on view is not the unsettling part. The unsettling part is that it's a preview. On March 23, 2025, Saturn's rings appeared edge-on from Earth. Their immense 282,000-kilometer width reduced to a knife edge just 10 meters thick in places, rendered virtually invisible. This happens every 13 to 16 years as Saturn's axial tilt cycles relative to our line of sight. But the rings are not simply hiding, they are dying. Combined infall rates give them fewer than 100 million years. They formed roughly when dinosaurs walked the Earth. They are 99.9% pure water ice, and their remarkable brightness is itself evidence of youth. Jupiter, Uranus, and Neptune may have once had spectacular ring systems that already vanished. The most beautiful structure in the solar system is dissolving. You are alive during the only moment in cosmic history when it exists. Number 8. The New Star. In 2023, astronomer Bradley Schaefer of Louisiana State University published a paper in the monthly notices of the Royal Astronomical Society analyzing 213,730 magnitude measurements of a binary star system spanning from 1842 to 2022. The system, a white dwarf of at least 1.35 solar masses locked in a 227-day orbit with a red giant companion 3,000 light-years away in the constellation Corona Borealis, is a recurrent nova. It last erupted on February 9, 1946. Schaefer predicted the next eruption at 2025.5 plus or minus 1.3 years. On September 22, 2025, the International Astronomical Union officially named it the Blaze Star. What makes this quietly alarming isn't the explosion, it's what the white dwarf is approaching. A characteristic pre-eruption dip in brightness was observed beginning March 2023, matching behavior seen approximately 1 year before the 1946 eruption. As of March 2026, the nova has not yet erupted, but remains imminent. The next viable windows fall around June 2026 or February 2027. When it detonates, it will reach approximately magnitude 2.0, comparable to Polaris, rising from completely invisible to naked eye brightness in a matter of hours. A new star appearing where none existed before. But the detail that lingers is the mass. The white dwarf sits at 1.35 solar masses, the Chandrasekhar limit. The maximum mass a white dwarf can sustain before electron degeneracy pressure fails is 1.4 solar masses. Every eruption adds accreted material that isn't fully expelled. The gap is closing. A star that has been invisible for 80 years is about to appear in the night sky, and every time it erupts, it gets closer to the mass where it can never erupt again, because next time it won't just burn, it will detonate. Number 7. The Fragment. On May 28, 2025, China launched the Tianwen-2 spacecraft toward a 40 to 100 meter asteroid designated 469219 Kamo Oaliwa, a quasi-satellite of Earth that orbits the Sun on a path so close to ours that it appears to loop around our planet once a year. In 2021, planetary scientist Benjamin Sharkey of the University of Arizona's Lunar and Planetary Laboratory published a paper in Communications Earth and Environment, reporting that Kamo Oaliwa's reflectance spectrum shows an L-type profile with extremely red reddening, matching space-weathered lunar silicates from the Apollo 14 Highlands samples. In 2024, Yifei Zhao of Tsinghua University published the source identification in Nature Astronomy. The asteroid was traced to the Giordano Bruno crater on the lunar far side, a 22-kilometer impact scar carved by a 1 to 1.7-kilometer impactor. The implication nobody wants to say out loud is what this rock proves happened next door. A kilometer-class asteroid struck the moon within the timescale of human evolution, 1 to 10 million years ago. The impact launched hundreds of 10-meter fragments into Earth-crossing orbits. Kamo Oaliwa is one of the survivors, a piece of the moon, blasted free by a catastrophic impact, orbiting silently alongside us ever since. Tianwen-2 will arrive in July 2026, collect approximately 100 grams of surface material, and return the samples to Earth in 2027. If confirmed, it will be the first time a specific asteroid has been conclusively traced to a specific impact crater. And the energy of the original impact, if the same object had struck Earth instead of the moon, would have been equivalent to approximately 1 million megatons, enough for a mass extinction event. There's a piece of the moon following the Earth right now. It was put there by an impact large enough to end a civilization, and it happened recently enough that our ancestors may have seen the flash. Number 6. The Hole in the Shield. In 2013, the European Space Agency launched the Swarm satellite constellation, 3 identical spacecraft designed to map Earth's magnetic field with unprecedented precision. In 2025, geophysicist Chris Finlay of the Technical University of Denmark published the definitive 11-year swarm analysis in the journal Physics of the Earth and Planetary Interiors. What the data revealed was a magnetic field in active decline. A massive weak spot, the South Atlantic anomaly, stretches across South America and the South Atlantic Ocean. Since approximately 2020, it has split into 2 distinct lobes, with a second cell developing southwest of Africa and weakening at an accelerated rate. And that's where it stops being a geophysics curiosity and starts being an infrastructure problem. Earth's magnetic field has weakened by approximately 9 to 10% over the past 200 years, declining at roughly 5% per century. The anomaly now covers an area nearly half the size of continental Europe. The International Space Station, the Hubble Space Telescope, and thousands of satellites pass through it regularly, experiencing elevated radiation levels that cause electronic glitches and force periodic shutdowns of sensitive instruments. The last full magnetic reversal, the Brunhes-Matuyama event, occurred approximately 780,000 years ago. The average interval between reversals is 250,000 to 450,000 years. We are statistically overdue. A full reversal would take 22,000 to 30,000 years to complete, during which the field could drop to roughly 10% of its current strength, with multiple wandering poles and no stable magnetic shield. Past reversals show no correlation with mass extinctions. Biology survives. But biology didn't depend on satellite networks. Earth's magnetic shield has a hole in it. The hole is growing, and nobody can tell you whether it's a fluctuation or the beginning of a reversal that takes 30,000 years to complete. Number 5. The Cage. In 1978, NASA astrophysicist Donald Kessler and Burton Core-Palais published a paper in the Journal of Geophysical Research describing a scenario in which the density of objects in low Earth orbit becomes high enough that collisions generate debris faster than it can decay, a self-sustaining cascade that renders entire orbital bands unusable. In 2025, J.C. Liu, NASA's chief scientist for orbital debris at Johnson Space Center, confirmed that the current debris population exceeds the runaway threshold at nearly all altitudes between 520 and 1,000 kilometers. The ESA Space Environment Report from April 2025 documented approximately 54,000 objects larger than 10 centimeters, roughly 1.2 million objects between 1 and 10 centimeters, and over 140 million fragments smaller than 1 centimeter. The scenario Kessler described in 1978 isn't a warning anymore, it's a status report. 3 events defined the crisis. China's 2007 anti-satellite weapons test destroyed the Fengyun 1C satellite, creating over 3,000 trackable pieces at 865 kilometers, increasing the known debris population by 15% in a single event. The 2009 collision between Iridium-33 and the defunct Russian Cosmos 2251, the first accidental hypervelocity collision between intact spacecraft, added approximately 2,300 fragments at 800 kilometers. And in November 2021, Russia destroyed the Cosmos 1408 satellite with an A-235 Nudol missile, creating over 1,500 trackable pieces just 80 kilometers above the International Space Station, close enough to force the crew into escape capsules. As of March 2026, SpaceX operates roughly 10,000 Starlink satellites, approximately 65% of all active satellites in orbit. A full Kessler cascade would destroy GPS, communications, weather forecasting, and internet satellites serving 5.56 billion users. Certain orbital bands could become unusable for generations. Launching through a debris belt to reach deep space would become extremely dangerous. We built a cage around our own planet, and if it closes, we may not be able to leave. Number 4. The Visitor. On June 19, 2004, astronomers Roy Tucker, Dave Tholen of the University of Hawaii, and Fabrizio Bernardi discovered a 340-meter asteroid at Kitt Peak National Observatory. On December 27th of that year, follow-up calculations placed its probability of striking Earth at 2.7%, 1 in 37, earning it a level 4 on the Torino Impact Hazard Scale, the highest rating any asteroid has ever received. The object was designated 99,942 Apophis, after the Egyptian deity of chaos. In March 2021, Tholen and Davide Farnocchia of NASA's Jet Propulsion Laboratory measured the Yarkovsky effect, a subtle orbital drift of 170 to 199 meters per year caused by asymmetric thermal radiation from its retrograde rotation, and ruled out all impacts through 2068 and beyond. The threat was eliminated. What wasn't eliminated is the flyby. On April 13, 2029, at 21:46 Universal Time, Apophis will pass just 31,600 kilometers from Earth's surface, closer than geostationary communications satellites, which orbit at 36,000 kilometers, and 10 times closer than the Moon. It will be visible to the naked eye at magnitude 3.1, comparable to stars in the Big Dipper, racing across the sky at 42 degrees per hour, covering 205 degrees of arc in a single day. Approximately 2 billion people across Europe, Africa, and Western Asia will be able to watch it with unaided eyes. If it hit, the impact energy would be approximately 1,200 megatons, comparable to the entire global nuclear arsenal. An event of this proximity is estimated to occur only once every 7,500 years. You will be alive for the only one in recorded history. On April 13, 2029, you will be able to look up and see a rock large enough to destroy a continent pass closer than the satellites that carry your phone calls. It will not hit. This time. Number 3. The Sholder of Orion. In 2023, stellar physicist Hideyuki Sayo of Tohoku University published an analysis in the monthly notices of the Royal Astronomical Society examining the pulsation periods of Betelgeuse, the red supergiant marking Orion's left shoulder, roughly 500 to 650 light-years from Earth. His models indicated that the observed periods are consistent with a star in late-stage core carbon burning, the penultimate phase before iron core collapse and supernova. Sayo wrote that a core collapse leading to a supernova explosion is expected in a few tens of years, though he later clarified the timeline could extend to a few hundred. In January 2026, Andrea Dupree of the Harvard-Smithsonian Center for Astrophysics published Hubble evidence of a companion star she named Betelgeuse b, whose orbit could explain the 2100-day period Sayo attributed to radial pulsation, potentially weakening the carbon-burning argument. The mainstream consensus places the supernova within 10,000 to 100,000 years, but what should unsettle you isn't whether it will explode, it's what it will look like when it does. At peak, Betelgeuse would reach apparent magnitude -12 to -13, as bright as the half-moon concentrated into a single stellar point, easily visible in broad daylight, bright enough to cast shadows at night. The Type 2P supernova profile means roughly constant peak brightness for 2 to 3 months, then a gradual fading over years. Orion, the constellation that has guided sailors, hunters, and civilizations for millennia, would permanently lose its left shoulder. At 500 to 650 light-years, Betelgeuse poses no radiation threat to Earth, but the light from the explosion may already be traveling toward us. It may have already happened. One night you will look up at Orion, and the left shoulder will be brighter than the moon. It will stay that way for months. And when it fades, that star will be gone. It has been there for every civilization in human history. After yours, it won't be. Number 2. The Storm. In 2012, physicist Pete Riley of Predictive Science Incus in San Diego published a paper in the journal Space Weather calculating the probability of a Carrington-class geomagnetic storm occurring within any given decade at approximately 12%. On July 23rd of that same year, a coronal mass ejection of Carrington-class intensity tore through Earth's orbital position, but Earth had been in that exact spot just 9 days earlier. Daniel Baker of the University of Colorado Boulder's Laboratory for Atmospheric and Space Physics published the analysis in Space Weather in December 2013, estimating the event would have produced a DST index of -1200 nanoteslas, comparable to the original 1859 Carrington event and more than double the 1989 Quebec storm. Every other entry on this list is something you can watch. This one takes away your ability to watch anything. On September 1st, 1859, the Carrington event set telegraph systems on fire, produced aurora visible from the Caribbean, and induced currents strong enough to operate disconnected telegraph machines on residual charge alone. On March 13, 1989, a geomagnetic storm with a DST of -589 nanoteslas collapsed the entire Hydro-Quebec power grid in under 90 seconds at 2:44 a.m., leaving 6 million people without power for over 9 hours. The 2008 National Research Council report, chaired by Daniel Baker, estimated a Carrington repeat would cause $1 to $2 trillion in first-year damage with 4 to 10 years for full recovery. Lloyd's of London updated their projection in 2023. $9.1 trillion globally over 5 years in the extreme scenario. The bottleneck is extra high voltage transformers, $3 to $10 million each, 12 to 18 months to manufacture, and limited spares worldwide. The May 2024 G5 storm, which produced aurora visible as far south as Cuba and Florida, registered a DST of -412 to -518 nanoteslas. A Carrington event would be 2 to 4 times stronger. The cumulative probability over 50 years, approximately 46%. There is a coin flip chance that within your lifetime, the sun will send a wave of charged particles that collapses the power grid across entire continents. No internet, no GPS, no hospitals, no warning you can act on. The signal arrives at the speed of light. The damage follows 8 minutes later. Number 1. The Superflare. On December 13, 2024, astrophysicist Valery Vasilyev of the Max Planck Institute for Solar System Research in Göttingen published a paper in the journal Science reporting that superflares, eruptions with energy exceeding 10 to the 34th ergs, occur on sun-like stars approximately once per century. This was 10 to 100 times more frequently than the previous estimate from Yuta Notsu of the University of Colorado Boulder, who had calculated a rate of once every 3,000 to 5,000 years in the Astrophysical Journal in 2019. In 2012, physicist Fusa Miyake of Nagoya University discovered sharp radiocarbon spikes in Japanese cedar tree rings dating to 774 to 775 CE, published in Nature. The carbon-14 increase was 12 per mil, roughly 20 times normal variation, corresponding to radiation levels approximately 80 times the Carrington event. The anomaly was independently confirmed by beryllium-10 and chlorine-36 measurements in Antarctic ice cores. At least 5 such Miyake events have been identified in 14,000 years of the record. Every other entry on this list assumes the Sun behaves the way it has during recorded history. This one shows it doesn't. A superflare exceeds 10 to the 34th ergs, roughly 100 times the Carrington event. The strongest eruptions observed on Sun-like stars reach 10 to the 36th ergs, 100,000 times Carrington. The 774 CE event, the strongest confirmed Miyake event, caused no problems for medieval civilization. There were no wires to melt, no transformers to overload, no satellites to fry, no ozone layer damage that anyone would notice without instruments. A repeat today would destroy the global satellite fleet in a single pulse. Power grids on a continental scale would suffer transformer damage requiring not months but decades to repair. The ozone layer would be severely degraded by proton bombardment. Astronauts and high-altitude airline passengers could receive potentially lethal radiation doses. Benjamin Pope of the University of Queensland estimates roughly a 1% chance of a Miyake event occurring in the next decade. 1% per decade. And there is nothing between you and it except 8 minutes of light-speed travel. The Sun has done this before. The trees recorded it. The ice recorded it. Medieval farmers didn't notice because they had no wires, no satellites, no grid, and no civilization that ran on electricity. You do. And the signal, the same signal that started this list as a whisper fading from the edge of the solar system, can arrive from the Sun in 8 minutes. There is no shield. There is no warning system that moves faster than light. There is only the star you were born under, and the fact that it has never promised to be kind. If you want to see more videos like this, click the video on screen now and make sure to subscribe.